Good morning, sir.
Good morning. Am I audible? Am I audible? Anyone? If you can confirm. Okay, we will wait for 3 minutes more. Students are still joining. After majority of them joins, we will start. Okay. In the meanwhile, you write your attendance in the chat box. Okay, students, let us start. if any one of you can confirm either via audio or via chat box if I'm audible or not, it would be very helpful. Anyone? Hello? Okay, I hope I'm audible. Okay, I hope my screen is visible to you. Okay, so we already Pinaki sir in the previous day in the lab, Pinaki sir has already discussed the basics of networking. Okay, so today we will again start with still the basics, but somewhat in more details. Okay, so first and foremost, to understand computer networks, we need to understand what is data communication. So the term telecommunication means communication at a distance. Okay, and the word data refers to the information that is presented in whatever form and is agreed upon by the parties creating and using the data. Okay, so which means if I want to communicate with some other person with some data, and suppose the person is at a distance, we say that we are telecommunicating with the help of data, right? And similarly, if we combine both of these definitions together, we can understand that data communication is nothing but the exchange of data between two devices via some form of transmission medium, such as a wire, cable, or the Wi-Fi medium. Okay, so we will understand what are the different types of mediums in this in the later half of the class. So whenever we are talking about data communication, generally data communication involves three entities. So the first one is the sender, the second one is the receiver, and the third one is the message. Okay, now the sender can be computers and the receiver can be computers, right? And the sender and the receiver, as you can see in the diagram, follow certain protocols. Okay, so whatever protocol the sender is following, the receiver has to follow the same protocol for the message communication to be successful, right? Which means, for example, we have all heard of the term IP address, right? Now what is the full form of IP? IP is nothing but internet protocol. Okay, so which means if I am sending data from a sender to the receiver via IP, right, which means the sender has to follow the internet protocol as well as the receiver has to follow the same internet protocol. Okay, similarly HTTP, UDP, FDP, TCP, all these are all kinds of protocols that we will study in the later half of the session. Okay, so both the sender and the receiver are computers that will follow certain protocols to send a data, right? The third one is what? The message, and the message in this case will pass through a medium. Now a medium, as we discussed in the lab classes, can be a twisted pair cable, it can be a coaxial cable, and can be a fiber optic cable, or can be through Wi-Fi. Now Wi-Fi, that is 802.15, it's a protocol. Again, it's a protocol. So we will follow this or we will see this protocol in the later half of the session. But for the basic thing that we need to understand, first and foremost we need to understand what is a twisted pair cable, what is a coaxial cable, and what is a fiber optical cable, right? Because this is the most important medium that we will talk about whenever we are sending data from a sender to a receiver. Now if you can see this diagram, we can see that
Hello, sir.
hello, tell me.
Sir, are you changing slides? Because in our screen the slides are not changing.
I think in full screen it is not changing. Just a second. Okay, I guess in full screen it is not changing. So I will just remove the full screen. Is it visible?
Yes, sir, it is visible, but the slides that you are changing, it's not
No.
like the change is not visible.
Now it's visible, right?
Yes, now the slides are.
Are changing, but again it is not changing now. What happened? Just a second.
Sir, you can just start a slide showing from the beginning so that we can understand.
So just a second. If I slideshow from the beginning,
Yes, yes, yes.
no, still you cannot see the full screen, right?
Yes, we cannot see the full screen, it's just the normal screen.
Okay. So if I do this, then it is changing, right? Okay, yes.
Yes,
So I
now
will
it is
just keep the
changing.
full screen and I will just show it like this. Okay.
Yes, sir, yes, sir.
Okay. So as I was saying that whenever we are talking about data communication, there are three components to a data communication. The first one is what? A sender. The second one is a receiver, and the third one is the actual message, the data, and the data by the medium through which the data will pass from the sender to the receiver side. So as I said earlier that sender and the receivers are actually computers that follow certain protocols. Okay. Now what are protocols? Protocols are some set of rules. Okay. Now let us understand like this, that suppose we are trying to send data from a sender to a receiver via IP. Now we have already all heard of the term what? IP. Now what is the full form of IP? It is internet protocol. Okay, so again it's a protocol, right? Similarly we have HTTP, that is hypertext transfer protocol, right? We have FTP, that is file transfer, FTP, that is file transfer protocol. So all these are a set of protocols. Okay. Now obviously whenever a sender is sending a data to the receiver, both the sender and the receiver will follow the same protocol that is defined whenever we are sending the message, right? Now what are these protocols? What are we will discuss all these kind of things in the later half of the session. Okay. And lastly we have the message, and we can understand that the message, that is the data that will be in the form of zeros and ones, will pass through something called as a medium, right? Now the medium can be of various types. So the main types that we see in our daily in our day-to-day lives are twisted pair cables, are coaxial cables, are fiber optical cables, and Wi-Fi, right? Now Wi-Fi again is a standard. It is known as 801.15. So again we will see these kind of standards protocols in the later half of the session. So for now, for the basic things that we need to understand the three types of cables, that are twisted pair cables, coaxial cables, and fiber optical cables. Now if I change the slide, you can see these three diagrams. So the first diagram is actually what is a twisted pair cable, right? So obviously Pinaki sir in the previous day in the lab, he showed you how to trim a twisted pair cable and the basics of a twisted pair cable, right? So we can see obviously that there are four groups of wires, and I guess in the lab you understood what is the whole concept of a twisted pair cable, right? Similarly we have something called as a coaxial cable. Now obviously a good example of a coaxial cable is that whenever in our homes we have TV connections and we have cable connections, right? So if you cut a cable wire, you can see that it's actually a coaxial cable, right? Now the coaxial cable has 5 parts. So the initial, the main part is known as the conductor. Okay, and after the conductor there is a isolation layer, and there is a foil shield, there is a braided shield, and then there is a outer wrapper. So by this also we can transmit data. Okay, and lastly we have something called as the fiber optical cable. Now we all know what how a fiber optical cable works. It works on the principle of total internal reflection. So again there is a core in which the actual total internal reflection occurs. Then there is a cladding, there is a coating, and then there is a sheet of plastic or rubber that actually gives strength to the whole wire, and lastly there is a outer jacket. So these three kinds of wires generally we use for physical data communication, right? And for the concept of Wi-Fi we will see that in the later half of the session as we discussed earlier. Okay, so we understood what is data communication. Now let us understand what is a network. Okay, so a network is a set of devices, as we already discussed that generally there are three parts of data communication: sender, receiver, and the medium. So a network is a set of devices, that is devices in this case means the sender and the receiver. So these are often referred to as nodes. Okay, so we will not say these are sender and receivers, we will say that these are kind of nodes that are connected with a communication link. So the communication in this case, link in this case will be what? Either coaxial cable, either twisted pair cable, or either fiber optic, or either Wi-Fi. Okay, so a node can be computer, a printer or any other device capable of sending and receiving data generated by the other nodes on the network. Okay, and a link can be either, as we discussed earlier, can be a cable, can be air, can be optical fiber, or any medium which can transport a signal carrying information. Okay, so I hope the definitions are clear to everyone. Now, generally, whenever we say that we have a computer network, there are certain criteria by which we measure a computer network, right? So the first criteria that we should understand is something called as performance. Okay. Now, what's the performance of a network? So, performance of the network depends on two things. So the first thing is it depends on the network elements, that is the nodes and the medium that we are using. So it depends, the performance depends on all these three kind of things: the sender, the receiver, which means the nodes, as well as the physical medium that we will use whenever we are transferring the data, right? And it is also measured in terms of delay and throughput. Now, what's the delay? Delay means nothing but how much time is required to transfer an amount of data, right? So suppose we have 1 MB of data, so how much time is required to transfer the data, which means as we discuss in our day-to-day lives, that the speed of the network is 2 Mbps, 3 Mbps, 1 Mbps. So what is that? That is nothing but the delay or the time taken to transfer amount of data is known as what? Delay. So a performance of a network is obviously measured in the terms of delay, right? The second thing is that the performance of a network is again measured in the terms of throughput. Now, what's the throughput? Throughput is nothing but how much data can be transferred from a source to a destination within a given time. Okay, so this is what it is known as throughput. So obviously the performance of a network depends on the network elements, the performance of the network elements, as well as the delay of the network, as well as the throughput of a network. Okay. Now, secondly, we can say the reliability of the network depends on two criteria. So the failure rate of the network components, so which means if the nodes fail or if the data communication link fails, then again the reliability will not be there. So again we can measure reliability on the depending on the failure rate of the network components. And secondly, we can measure reliability with the help of the availability and the robustness of the nodes as well as the data communication links. Okay, and lastly, we can measure the security of a network based on two criteria. The one is so the data protection against corruption or loss of data due to what? Errors as well as malicious users. Now, what are errors? So we have mechanisms for error detection, error correction. So we will discuss these in the later half of the session. So whenever we are sending data from a sender to a receiver, so before delivering the data to the receiver, it will be checked for errors, right? So the first and foremost, the error will get detected, and obviously if the situation demands, the error will get corrected as well before being delivered to the actual receiver. So we will see this, how it is, how the errors get detected, how the errors get corrected. We will see everything, the mechanisms in the later half of the sessions. And lastly, we have malicious users, which means hackers. So again, in a network there can be various ways by which a network can be hacked. So again, the security of a network depends on how much it is susceptible to getting hacked and like that. Okay, so these are the things by which we measure how much good a network actually is. Okay, so so we again need to understand, so whenever we are talking about a computer network, obviously the nodes that we talked about earlier in the class, the nodes have to be.
Sir,
Tell me.
sir, in the previous slide, you said it is measured in delay and throughput.
Yes.
Means delay same as latency.
Delay is very much similar to latency. Very much similar to latency. That is what I can say. Okay, it is not fully the same, but it is very much similar. Okay, we will see the definition of latency, throughput, delay, everything in the third or the fourth class. Okay, just wait for that. Okay, so again we will understand that whenever we are talking about nodes, the nodes can be organized in certain ways, right? So so we can say that if I talk about the types of connection, the connections can be point to point. That means it will have a single transmitter and a single receiver, which means a single sender and a single receiver, and it can be multi-point, which means multiple recipients and a single sender, right? as well as we will talk about some topologies, right? Now, what are these topologies? We will see in the later half of the slide. So, first and foremost, we will understand what point to point and a multi-point connection looks like, right? So, which means in the first diagram, if we can see that if a sender is there and he is directly connected to the receiver via a link, and there are no other nodes or computers in that in between that link, we call it as what? A point to point connection between the sender and the receiver, right? And similarly, if I have a single sender and through a link he is transmitting the data to multiple receivers, then we can say that it's the sender and the receiver are in a multi-point connection, right? Okay. So secondly, we have something called as a topology. Now topology means what? How the nodes of a network are actually arranged. Okay. So there can be four types by which we can arrange the nodes. So the first one is mesh. The second one is a star topology. Third one is a bus topology, and fourth one is a ring topology. Now I will quickly move through this. There are certain advantages as well as disadvantages of these topologies, and this will be present in the PPT. I will share the PPT with you. Okay, but first and foremost, let us understand what the topologies actually look like, right? So this is a mesh topology of 5 devices. So as we can see in the diagram that all the devices or all the nodes are connected to each other, right? So just remember this point, that all the nodes in the network are connected to each other. So this is nothing but something known as a mesh topology. Okay. Now there are certain advantages of mesh topology. I have listed various advantages and disadvantages. So we will go through these. I will just discuss the main points. Okay. Now what's the advantage? The advantage is that the arrangement of the network node is such that it is possible to transmit data from one node to many nodes at the same time. So this is the advantage of what? The mesh topology, right? And what's the disadvantage? Disadvantage is that it requires a large amount of data wire or the communication link that will be present to design this network topology. Okay, so this is the important advantage as well as disadvantage. There are various others. I will share the PPT with you. You can see those by yourself. Okay. Second one is something known as what? A star topology. Now as we can see that if we have a central hub, right? Now what's a hub? What are all these kind of things? We will discuss in the later half of the classes. So if I have a central hub, and we can see here that all the nodes are connected to the central hub, right? Which means whatever data comes into the hub will transmit all the data to all the nodes that are connected to the hub. So this is nothing known as what? A star topology. Now what are the advantage? So advantage is what? That due to its centralized nature, the topology offers simplicity of operation. So this is the main advantage. Okay, and the main disadvantage is what? That network operation depends on the functioning of the central hub. So which means if the central hub is malfunctioning, then the whole network will crash. Okay, so these are the main advantage and the disadvantage of a star topology. Okay. So thirdly, we have something called as a bus topology. Now bus in this case means the communication link. As in computer we have buses, data buses, right? So similarly, bus in this case it actually means what? A communication link. So we can see that we have a communication link here, right? And all the nodes are connected to the same communication link, right? So we can say that this is nothing but something called as a bus connection. Okay. Now what is the main advantage and disadvantage of this? So the main advantage is obviously we can understand that it is very easy to set up, handle and implement. Okay, so that is the main advantage. And what's the disadvantage? Again, the cable length is limited. Okay, so this limits the number of network nodes that can be connected to the bus or to the communication link. So this is the main advantage and the disadvantage of a bus topology. And lastly, we have something called as a ring topology. It is very similar to a bus topology, but the difference is what? If I just give an example of a linked list and a circular linked list, so it's the same thing. So we have a bus, and the starting point of the bus and the ending point of the bus are connected to each other. So this is nothing but a ring topology. Okay, so we can understand what the ring topology looks like with the help of the diagram. Now what's the main advantage and disadvantage of this? So the main advantage is what? The data being transmitted between two nodes passes through all the intermediate nodes, right? Which means the central server is not required, like in the case of star topology. Okay, and what is the main disadvantage? Again, the failure of a single node in the network can cause the entire network to fail, which means if I can see here, all the nodes are connected to the bus, which means if a data is passing from this station, what happened? Again, the slides are not changing. Okay, so if the data passes from the first station to the third station and the second station in this case is malfunctioning, then again we can say that the network will crash. Okay, so it will depend on the robustness of the nodes that are inside the ring topology. Okay, so all the topologies that we have discussed now will have some advantage and will have some disadvantage. Now what we do is to mitigate or to take advantages of every topology, as well as to mitigate the disadvantages of every topology. What we can do is we can do something called as a hybrid topology. Now you can see here, so if I see at the hub, which means this is what, this is actually a star topology, right? Now again, if I see the first part, the second part and the third part, we can see that these are actually but bus topologies, right? So like this we can concatenate topologies together to make something called as a hybrid topology, which will mitigate the disadvantages of the single topologies and can rake in the advantages of the single topologies together. Okay. Okay. So as we discussed earlier, the hybrid topology combines two or more topologies and is meant to reap their advantages. And obviously, the advantage and disadvantage of a hybrid topology are a combination of the merits and demerits of the topologies used to structure the hybrid topology. Okay. Now again, we have discussed that there is something called as a unicast communication, multicast communication, and broadcast communication. So again, it is very much similar to the point-to-point and multi-point connection that we discussed earlier. So we can see with the help of the diagram that whenever we have a unicast communication, which means a single sender sending to a single receiver, right? Similarly, whenever we have a broadcast connection, which means a single sender is sending to all the receivers, right? And whenever we have a multicast connection, it means that a single sender is sending to not all the receivers but some receivers, that is, there will be more than one, so more than one receivers but not all the receivers in the network. So that is something called as a multicast connection. So again, we can remember it by like this. So a unicast connection is actually one-to-one connection, the broadcast connection is actually a one-to-all connection, and a multicast connection is nothing but a one-to-several connection but not one-to-all connection. Okay. Now we will discuss some of the network devices that we see in our day-to-day lives. So the first one, as we discussed in the topology, is something called as a hub, right? Now what's a hub? A hub connects multiple computer networking devices together. Okay. A hub is the simplest in the family of network connecting devices because it connects LAN components with identical protocols. Okay, and there can be two types of hubs. One is a single point hub and one is a multi-point hub. Now by the diagram we can understand a hub is nothing but, suppose we have a network, suppose we have a computer and I want to connect this computer to a computer that is just beside me. Okay, so I can use what? I can use a hub. I will just plug in my Ethernet cable to that hub, right? The computer that is beside me will connect its Ethernet cable to the hub, and both of my computers will be connected to each other via that hub. Okay, so if I use three computers like this, so we can say that there is a central hub, and again these three computers will be connected with the help of what? A star topology, if you can remember. Okay, so again as we discussed earlier, a star topology, what's the main disadvantage? That if the hub fails, then all the three computers that were connected to each other will not be connected to each other now if the hub actually fails. Okay, now this is by the diagram you can understand that how a hub actually looks like. Okay, so if you ever encounter a device like this that looks like this, it's actually what? Nothing but a hub. Okay. Then there is something called a switch. Now if you come to our lab or go to any other office, I guess Wong ma'am today will show you switches. Sorry, in the next lab class we will try and show you some switches, and we will try and show you what the switch actually does. So to understand, so first and foremost, in the diagram you can understand or you can see how a switch actually looks like. So the first one is a 5-port switch, the second one is a 24-port switch, and the third one is what, a 48-port switch. Now like this there can be 100-port switches and everything. So we will see these in the practical classes. Okay. Now switch is nothing but it generally has more intelligent role than hubs. Now how it is intelligent I will discuss. Okay. So a switch is a multi-port device that improves the network efficiency, and the strands of LANs are usually connected using a switch, and generally a switch can read the hardware address of the incoming packet to transmit them to the appropriate designation. Now as discussed in the lab class by Pinaki sir, we discussed that a computer will have two kinds of addresses. One is a physical address and one is a virtual address. Now the physical address is nothing but a MAC address, and the virtual address in this case will be something called as a IP address, right? Now a switch is an intelligent device. Now what it does is it will have a switching table. It will maintain a switching table, right? Now what the switch will do? Now let us take for example that we have a cluster of 10 computers that need to be connected to the internet. Okay, so we will connect these 10 computers suppose via a hub, and the hub I will connect it to a switch. Okay, so again if I say that again I have a cluster of 10 computers and I want to connect these 10 computers to the internet, so what I will do, I will again connect these 10 computers to a hub, and I will connect this hub to a switch. So now what is the function of a switch in this case? So a switch will connect two networks of the same type. Okay, so a switch connects two networks of the same type, and since I said that it's an intelligent device, which means what it does is it will maintain a switching table. Okay, now what does the switching table have? It will have the MAC address or the physical address of every computer that is inside the cluster. Okay, so which means if someone outside my network wants to send data to a certain computer that is inside my network, okay, so what it will do is it will send data from the outside world to the switch, and the switch being the intelligent device that maintains a switching table, it will just correspond. Suppose the data is coming from the outer world, so the data will have the MAC address of the user that the data is intended for. Okay, and the switch will check its switching table to see that the computer to which the data will be delivered belongs to which cluster, belongs to which network, and to whatever network the data will belong to, the switch will send data to that cluster of network, right? So if you remember earlier we had two clusters. So suppose the data belongs to the computer in the first cluster, the switch being intelligent will send the data to the first cluster and not to the second cluster. Okay, so what is actually switching? Switching can be various types: packet switching, circuit switching, message switching. We will discuss these kind of things in the later half of the session, and what are switching tables, etc. We will again discuss all these kind of things in the later half of the session. Okay, now there are 12 more slides that I needed to cover today, but again all of you have the IMCRP exam code, right? And the exam actually starts from 10 o'clock. So it will be starting from 10 o'clock, and the time will be till 10:20. Okay, so again we will stop today here. We will continue this PPT in the next class as well. I will share this PPT in a Google Classroom. I have also given the Google Classroom code in the WhatsApp or in the daily class tracker. So again you need to join that Google Classroom. You will get the PPT and you will get the live recordings link as well in the Google Classroom. Okay, so what I want you to do is I want you to go to the IMCRP exam right now. Okay, give the IMCRP exam, and just remember that if you don't give the IMCRP exam, your attendance will not be counted. Okay, so after giving the IMCRP exam, your attendance will come to us, and then we can mark your attendance. Okay, so I hope whatever I have taught till now is clear. If you have any questions, you can reach out to me via mail, via WhatsApp, and via calls. Okay, so you can leave the session and you can go and give the IMCRP exam now. And if any one of you have any questions, you can stay back and ask me the question.
Sir, please give the IMCRP link.
IMCRP link was there in the WhatsApp group. Still, I will post it. Just wait. Just IMCRP link means the exam link or the exam code? What do you want?
Exam link, exam. Where should I give the exam?
Just first I will give the exam code and then I will give the exam link. Just a second. So see the chat box, I have given the link.
Thank you.
Okay. So again I will be there in the session till 10:20. If you have any problems for today's class, you can come back and ask me. And the exam link will be valid till 10:20. So try and give the exam before that.